Hello students, today we'll see working of a MOS transistor. Okay, so in the figure it's a simple MOS transistor structure. What I've written here, it shows a simple MOS transistor structure. The top layer of the structure is a good conductor of gate, that is polysilicon gate, and the middle layer is a very thin insulating film of silicon dioxide called a gate oxide, silicon dioxide insulator. The bottom layer is doped by silicon body. So the body is grounded and a voltage is applied to the gate. As you can see in the diagram, body is connected to ground and the gate is connected to a positive voltage. Okay. Uh, a negative voltage. VG is less than 0. Voltage is applied, negative voltage is applied to the gate. So there is no negative charge on the gate. The mobile positively charged holes are attracted to the region beneath the gate, as you can see here. This is called the accumulation mode. This is called as the accumulation mode of a MOS transistor. Okay. So now, as you can see in the figure, what we have done is we've started applying a small positive voltage at the gate terminal, which results in some positive charge on the gate. The holes in the body has repelled from the region directly which is beneath the gate, resulting in a depletion region forming below the gate. As you can see here, some near to the region, what is happening, which is depleted from charge carrier, so we can call it as a depletion region. Okay, so now in this, what we do is we apply still more higher positive potential which exceeds a critical threshold, which exceeds some of the threshold voltage here. VT is applied, which attracts more positive charge to the gate. The holes are repelled further and some free electrons in the body are attracted to the gate. So this conductive layer of electrons, as you can see here, this conducting layer of electrons is called as the inversion layer. Okay, this is the inversion layer of a MOS transistor. So depending on the gate terminal, it operates in accumulation mode, depletion mode, as well as it forms an inversion region when you apply and you go gate voltage more than the threshold voltage. So, and this is a structure of an NMOS transistor, whereas the body is P-type. Okay, the transistor consists of a MOS stacked between two N plus regions. These are the two N plus regions. Okay, the gate to source voltage VGS is less than the threshold voltage. When VGS is less than the threshold voltage, the source and drain have free electrons and the body has free holes but no free electrons. Suppose the source is grounded, the junction between the body and the source or drain are zero, biased or reverse biased, or little or no current flows, the transistor is off, and this mode of operation is called as cut-off operation of a transistor. Okay. So when the gate voltage is greater than the threshold voltage, now an inversion layer forms here, as you can see in the diagram, called the channel. With this, that is called as the channel, which connects source and drain, creating a conductive path and turning the transistor on. So this is the inversion layer which is connecting source and drain and which turns on, and at this particular condition we tell the transistor is on. The number of carriers and the conductivity increases depending on the gate voltage. So when a small positive potential, now with this gate, keeping this gate voltage, when a small positive voltage is applied between the drain and source terminal, current IDS flows through the channel from drain to source, and this mode of operation is termed as linear resistive triode or non-saturation or unsaturated region. The current increases with both drain and gate voltage. If VDS becomes sufficiently large, if VGS is large enough, the channel is no longer inverted near the drain and becomes pinched off. This is called as pinch off region. It is pinched off, however, the conduction is still brought by the drift of electrons under the influence of some positive drain voltage. As electrons reach the end of the channel, they are injected into the depletion region near the drain and accelerated towards the drain. Above this drain voltage, the current IDS is controlled by the gate voltage. This gate voltage, and it ceases to be influenced by the drain. This mode is called as saturation region. So basically there are three different regions of operation of a transistor. When VGS is less than VT, the transistor is cut off. When VGS less than VT, transistor is what? Cut off. That is, transistor is off. When VGS is more than VT, transistor is on. Okay. And if VDS is small, transistor acts in the linear region and current flows. When VGS is more than VT and VDS is very high, what happens? The transistor acts as a current source in which the current flow becomes independent of VDS. So these are the three different operations of a MOS transistor.